So the end-to-end path simulation function is it can be obtained very, very easily. And the advantage over the GUI simulation that you will have all the information in a structured form, which will be the JSON, and we will observe that in a minute. So the end-to-end path function will look like this. The only thing you need to input is the query and the headers. The query will include the API endpoint for the request, and the request is simple. It's going to be simply GET request because you cannot change anything, right? All the source and destination IP address will be included in the query. That's how it works. Here's a little check for checking if the response is okay or not. It doesn't mean that the simulation is done properly. It only means that the response is okay. And in return, we will get the response itself that we can observe and investigate further on. So let's have a look how the simple end-to-end path simulation can be run through an API. This is a quick scriptlet, how you can define all you need. Here is a very, very long dictionary, which will be including the endpoint, source IP, destination, source, port, the asymmetry. We don't need to play with it now. The RPF option, protocol type, and the snapshot ID. The snapshot ID is different because you need to use a snapshot ID. If we go back to the IP fabric, because we remember we can get the snapshot IDs through an API as well if we call the get snapshots function. If you want to check where you can find the snapshot ID in the GUI, you can find it at the following place. If you go to the URL, this is the snapshot ID, right? Or pretty much anywhere. If I go to the inventory and devices and ask for the API, again, this is the snapshot ID. So we go back to the discovery snapshot because this is the snapshot with only 2 devices. I don't want to run a simulation dead because there's not going to be the information I'm looking for. I want to run a simulation in this particular snapshot. So I want to define the snapshot ID. So if we go back to the function, here where we're going to define it, so it's going to be the same. So again, I'm going to prepare the end-to-end query, which will be consisting of following parameters. So right now I'm going to create the end-to-end query, which is going to be an empty string, and I'm going to put all the values from the dictionary. Okay. And this is how it looks like. So it is the endpoint and kind of a payload at the same time. If you imagine that you're not posting, but getting information from a certain endpoint. So that's a little bit of analogy to that. So let's call a function and see what we have in response or in return. Okay, seems that the simulation is ready. It only means that we have the correct response that we expected. Let's see what we have in the simulation itself. So the JSON. Let's see what keys we have. So we have 2 keys right now. The response is either graph and AD. If there is an error in the end-to-end path, we will get another key called error. But we have only graph and AD right now, which means it seems to be successful, but we need to observe all the hubs to make sure. The graph will include all the information about all the hubs that the packet is traveling from the source to destination. The AD is a list of the sites as they are defined in the IP fabric. So we can see what we have in the AD. All right, and it seems that there's only one site. So the packet is traveling only within one site. So it's not leaving the site. And now let's see what we have in the graph. Okay. So this is all the information we have in the end-to-end. And you see, it's a very structured information because it's showing you all the information about layer 2, layer 3, the security portion. It will show you all the source and the exit interfaces. And so, for example, let's analyze the endpoint path more closely. So we see in return we have a dictionary. Then there's nodes, and there's just a list of the nodes. Now, the nodes are going from 0 to whatever number. They are the exact hops. So they are ordered in a way that end-to-end path was simulated. And this is very important information to know. So if we check for nodes, we have the list. So what we can do, we can define a node list, which is going to be the list for n in node list. And let's see what we can have. So we have device type, router, forwarding, and let's search for the host name. Here we go. Okay, so this is at least what we can have. We have basically the traceroute hops, but they are not only traceroute hops because it works also on layer 2. And see, it's ordered the other way around. Because if we go back to our end-to-end path simulation, the source IP was 112. And you realize that we searched for the host name. The reason for that is the last hop in the list is the originating host. So it's not a router, but it's defined as a host in the IP fabric. That's why its host name is just the IP address. The next hop is layer 2. I think that this one is the first layer 3 hop. The second layer 3, another layer 2, layer 3, and the last hop. So the list is reversed. When you going from the source to destination, it will actually show you the destination where the end-to-end path ends as a first part in the list. So again, I hope that the webinar was helpful and informative for you. I hope you enjoyed it. I hope that you enjoy more webinars. There's more to come. We will definitely touch the API again. We will do other webinars focused on security. We'll do other webinars focused on more simulation and the new features that we have in IP Fabric, because with the 3.5.0 version in the IP Fabric, we have just started with the API-based discovery, which is a great stepping stone for any further focus on the SDN networks, the networks in the cloud, and there's more to come. So I want to again thank you for watching and have a great day.